Hey guys, today we are looking at 5.4's note, which is all about solving radical equations. So, as the name implies, a radical equation is just an equation that has your variable underneath the radicand, or underneath the radical. So, since we're trying to get rid of that square root, cube root, fourth root, whatever the radical is in my problem, to get to my x value underneath, we're going to be needing to do those inverse operations to get rid of our roots, which is just exponents. Like we talked about earlier in chapter 5 before break, we know that roots and squares, roots and exponents are kind of inverses of each other. So if we're trying to get rid of a root, we're going to need to raise it to an exponent power. So I've got some formal steps written out here in the notes, but it's pretty straightforward as we usually do. We're going to try and isolate the radical to get that thing by itself. That way we can raise that exponent to get rid of my root and then solve from there. Once our radical is gone, once our variable is outside the radical, we can go through and solve using any of those prior skills that we've learned, whether it's solving a linear equation, using those factoring skills to solve our quadratics, or something else. It's going to be usually one of those two, but you'll see once you have the variable outside of my absolute or outside of my square root, we're going to just go through and solve from there. So our first type of problem, we're just solving some square roots, which are going to be probably the most standard. As usual, we're going to work on getting rid of our other gunk. We're going to get rid of our 2 in this case that's multiplying my square root. And since it's multiplying my square root, I'm going to have to divide on both sides. So those cancel each other out there. That leaves me with my square root of x plus 1 equals positive 2. Underneath my radical does not change. It's just dividing by 2 to get rid of the multiplication by 2. So from here, now that I have my radical by itself, even though I don't see a root written here, we know that anytime we're square root, if we don't see a number written there, it's implied that it's a 2 because it's the square root. So if I'm trying to cancel that out, I would have to square both sides, because what I do on one side of my equation, I have to do to the other. So doing that, squaring both sides, that cancels out my radical and my exponent on the left side, leaving me with x plus 1. And then over on the right side, 2 squared is positive 4. And from here I can just solve the remaining equation, which super easy. Whoops. If I can write numbers correctly, we're going to subtract 1 on both sides, and we get positive 3 for my solution. All right, moving on to number 2. Same idea here. Now this one a little bit more challenging because we've got radicals on both sides. But the nice thing is it's just radicals on each side. There's nothing else mixed in there. There's no other separate terms. It's just a radical term on the left, a radical term on the right. And in this case, it's even nicer because they're both square roots. So what I can do is just right away square both sides. If I squared both sides, my square roots cancel on the left, leaving me with 2x plus 5. My square root and my squared cancel each other out, leave me with just x plus 7. And from here, I just solved the old-fashioned way. This is something we've been doing since first semester Algebra 1. The very first thing we learned how to do was going through and solving linear equations. So I'm going to get my x's on the same side, move the x over to the left. That leaves me with x plus 5 equals positive 7. Subtract 5 on both sides, and we get x equals positive 2. Okay, so those are my square roots. In box 3, we're now dealing with cube roots, which does not change anything other than what we're going to raise my root to. Because in a cube root, we can see here, we've got the little 3 there in my radical, the little root indicating that I'm trying to figure out what 3 times is the thing underneath my radical. I'm still going to start by isolating my radical first. So in this one, I have to add 1 on both sides first to get my radical by itself. 2x minus 9 underneath my cube root. So that gives me 3. So now to get rid of that root, I have to raise it to the same power. So since I have to do a cubed on the left side to get rid of my cube root, which those will cancel each other out now, on the right side there, I have to do 3 cubed, 3 to the 3rd power. So 2x minus 9 equals, you can use your calculator or your super big brain to know that 3 cubed is 27. And from here, we'll go through and solve as we know how. Add 9 on both sides. 2x equals 36. Divide by 2 on both sides, and we get x equals 18. X equals 18. All right. So on number 4, the only thing happening to my root is that it's being multiplied by 2. So just like with the very first problem we did, we'll divide by 2 on both sides first. Cube root of x minus 3 equals 2. It is cube root, so we're going to have to cube the left side and the right side to cancel out my radical. That gives me, those cancel out. X minus 3 on the left. 2 cubed to the third power is 8. So I add 3 on both sides, and we get x equals 11. All right. Last box, box number 4, which, as you can see on the title, talking about extraneous solutions, we are going to deal with some problems where you're going to end up with multiple solutions. And like we've seen in every situation where you have multiple solutions, some of them or one of them could be extraneous. And if you've forgotten, extraneous just means an extra solution that we get during the process of solving, but when we go back and check our answers, it doesn't actually make my equation true. And usually it has to deal with sign differences of things depending on what the operation that we're dealing with is. So to start with here, number 5, we've got x plus 1 on the left side. We've got my square root of 7x plus 15 on the right. My square root is already isolated, so I know that I have to square that right side to get rid of my square root. But what I have to be careful with here, this left side has to get squared, but I have to square the entirety of my left side. Let's change that 2 there. There we go. So when I do that, this is a common mistake that a lot of us still made even on the final, that when we square an expression, when we square a binomial, x plus 1, there's a lot of us who are still just squaring my x and squaring my 1, which is not the case. Remember, x plus 1 squared is the same thing as x plus 1 times x plus 1. We have to multiply it by itself, multiply it by the same parenthesis. So when we go through and FOIL, x times x times 1, 1 times x, 1 times 1, on the left side, after we've FOILed and collected our like terms, we actually end up with x squared plus 2x plus 1. And then over on the left side here, my square and my square root cancel each other out, so I'm left with 7x plus 15. The nice thing is, now that my square root is by itself, is gone, I can push everything over onto one side and solve using methods that we learned last semester. So we'll subtract 7x on both sides and subtract 15 from both sides to get it equal to 0. X squared minus 5x minus 14 equals 0. That is we can factor that out usually using the old school 2 parentheses factoring, right? What 2 things multiply together to give me negative 14 but add up to negative 5, which in this case should be x minus 7 and x plus 2. Negative 7 and positive 2 multiply to get negative 14, but add up to a negative 5. So zero product property allows us to solve each of those 2 parentheses by setting them equal to 0, and we should get x equals positive 7 from this first one, and x equals negative 2 from my second one. So from here, now that I have my 2 solutions, I have to check my answer. Now, this is not something that you always have to do. I would definitely suggest it when you have multiple solutions, because as we go through and check these, I'm going to switch it over to one of my fancy pens. There we go. Let's do lava. If I plug in 7 into my original problem, so 7 plus 1 equals the square root of 7 times 7 plus 15, and that gives me 8 equals the square root of 49 plus 15, which is 64, so 8 equals 8, and that checks out. That's good. 7 is the solution. 7 is correct. We can go ahead and box that one in. But if I did the same thing with negative 2, I end up having an issue here. Because if I plug that in, negative 2 plus 1 equals the square root of 7 times negative 2 plus 15. That gives me negative 1 on the left side over there. And without even having to finish this really, I should know that that's going to be an issue because my square roots are always positive. We never had any negative square roots at all, right? It's either imaginary, non-real answer, or it's positive, or 0. So we should be able to, like, intuition should tell us that it's not a solution. But finishing this off, and showing that it's not true, square root of negative 14 plus 15 gives me the square root of 1, which 1 is not negative 1. And that's the issue, it's the sign. So the negative part is the issue. If it was a positive 2, maybe it would work out nicely, but this is extraneous. So however you want to note that, if you want to say extraneous, if you want to cross it out, or box in the positive 7, but don't box in or circle your answer for negative 2, just indicate to me that you know that one's actually not a solution, even though you got it as an answer. Okay, let's try one more. And if you didn't notice, the 2 here that we're seeing is extraneous solution. The only way it's possible to get an extraneous solution is if your square root, your variable is outside of my radical. So all of my other ones so far haven't had an extraneous. I haven't had any variables not underneath the radical. 5 is the first one where we had a square root, or we had a variable outside my radical, and that's kind of queuing you up that. And another thing besides getting 2 solutions that you might deal with extraneous. All right, so taking a look at the last one, number 6. I've got my square root isolated right away, so I can square that left side and do the same thing to the right. So my square root and my squared cancel out, leaving me with just 10x plus 9. Squaring that right side, we kind of have to do the same thing. We have to know that x plus 3 squared is really x plus 3 times x plus 3. So you can go through and FOIL, firsts, outsides, insides, lasts. We should end up with x squared plus 6x plus 9 when we fully expand that out. So from here, subtracting 10x from both sides, subtracting 9 from both sides, gives me 0 equals x squared minus 4x. And that's it, actually, because my 9 and my negative 9 cancel out. So that's nice because now I can just GCF. X squared and negative 4x have an x in common, leaving me with x minus 4. So my 2 solutions should be, let's do this in a different color. My 2 solutions should be 0 and 4. And neither of them are negative, so I actually don't think either of these are extraneous, but when we have 2 solutions, and especially when you have a variable outside the radical, it's a good idea to check it anyway. So I'm going to go ahead over here and let's use lava again. If we do 0 first, if we check 0, square root of 10 times 0 plus 9 is supposed to be equal to 0 plus 3, which 10 times 0 is just 0, plus 9 is 9. So we end up with square root of 9 equals 3, so 3 equals 3. So 0 checks out. It is a solution. Let's do ocean. If we do that with 4, the square root of 10 times 4 plus 9 is supposed to be equal to 4 plus 3, which 4 times 10 is 40. Plus 9 is 49. Square root of 49 is 7. So both of these check out. We don't have an extraneous here. It's not required if we have 2 solutions. You might have both of them work like we see here with number 6. But it's something to be aware of, something to be careful with, and then obviously if you do end up with an extraneous solution in one of your problems, you do have to make sure you either say it's extraneous or don't include it when you list out your answer. All right, that's all we got for 5.4. Your homework tonight, well, really tomorrow, is going to be page 266, 4 through 26, just the evens. As always, if you guys have any questions, concerns, thoughts, ideas, hopes, or dreams, make sure you guys are reaching out and letting me know. Otherwise, have a great day. We'll see you soon.